Hello, everyone. Welcome to the last day of the PASS Summit. We're going to start. Our session now. It's called "Practical Guidance to Make Your Tier-1 SQL Server Roar." And my name is Pedro Lopes. I have with me Pam Lahoud. Let's start with cleaning house first. I hope you had a chance to explore everything PASS has to offer, from knowing about your local user group to virtual groups and volunteering options. You can go to pass.org and see all that's available there. And please fill out your session evaluation. It's important at the end of the day for us to know if you want us back, if you want to see something different. So all feedback is important to us. So my name is Pedro Lopes. I'm a principal program manager in Azure Data, specifically the SQL Server team. I mainly take care of SQL Server on Windows, and in the last few years, I've been focusing on the relational engine, which is basically everything that makes your queries execute and provide you a result set. So my main focus is query processing and programmability. You can get in touch with me with the contacts you see on the screen there, either LinkedIn, or I'm active on Twitter with SQL Pedro. My DMs are open. You feel free to reach out. Have with me Pam.
Hi, folks. Thanks, Pedro. My name is Pam Lahoud, and I'm also a program manager on the Azure Data team. I am currently the lead PM for SQL Server on Azure Virtual Machines, and I also help manage the storage engine area and SQL OS within the SQL Server product. Similar to Pedro, you can reach me on Twitter. That's usually the best way to get me. I'm at SQL Goddess, and feel free to ask us follow-up questions there. One more bit of housekeeping, we're going to get cut off straight at 75 minutes. So if we have a tendency to talk a lot and run long. So if we need to, we can always do follow-up questions on Twitter. And also there is a Discord channel too we could go chat on. So feel free to reach out to us if we have more questions after the session. So with that, let's get started with what do we mean by a Tier-1 SQL Server? So essentially, a Tier-1 SQL Server is a server where performance really counts. These are your high-end, enterprise-level, business-critical servers. So high-end might mean high-end hardware, so a large number of cores and a large amount of memory. Could also mean very large databases, several terabytes, hundreds of terabytes even of databases. Could also mean heavy analytical processing, so data warehouses, big queries, very important like end of month reporting, things like that. Could also mean high transaction throughput, so your incredibly busy concurrent OLTP systems. Or it could mean systems that have very strict HADR SLAs, where uptime is incredibly important, business can't afford downtime. So any system where you really need to ensure that that system is up and processing and performing as well as it can at all times. These are what we talk about when we say Tier-1 SQL servers. So what we're going to do today is talk about a whole bunch of best practices. What we've got for you is collectively over 40 years of experience running SQL Server, and this is literally going to be a brain dump for you of everything that's in our heads. Best practices for performance at every level. So we'll start with hardware, with the platform and the configuration. We will move to the operating system level. We'll talk a little bit about that. Then we'll move to the SQL Server level. We'll talk about settings, configuring tempdb, trace flags, things like that. And then we'll go down to the application level and talk a little bit about query performance and database maintenance. So when you're running a Tier-1 SQL Server, a problem at any one of these levels could cause the whole system to have issues, either latency or stability or what have you. So they really build on top of each other. So you've got to ensure that everything is configured correctly at each level, and that's what we're going to talk about today. All right, so let's start with the hardware part. So the platform, where can you run SQL Server? Well, these days, if you've been watching any of our presentations on SQL and on Azure SQL, you know we run on pretty much any platform you want. So you could run SQL Server on a physical server. You could run it on a virtual server. You could run it in Azure or in another cloud provider as infrastructure as a service. Or you can run in one of our platform as a service. So that would be like Azure SQL DB or Azure SQL MI or Hyperscale or one of those options. Now, when you're dealing with configuration for those PaaS services, there isn't really much for you to do because the whole point of a PaaS service is to have Microsoft manage that for you. So we're not going to talk so much about PaaS, although some of the application stuff that Pedro's going to cover later as far as query performance, query tuning, and database maintenance, that might also be relevant for PaaS. But most of what we're going to talk about today would be if you're managing SQL Server yourself in either an on-prem or in IaaS in Azure or another cloud provider. Okay. Losing control. Okay, so let's start with running SQL Server in a physical server. So first things first, when you're thinking about how to configure your SQL Server, you really want to think about what kind of a workload are you running. So typically this is one of two, either OLTP, which is a transactional workload, or OLAP, which is analytical or data warehousing workload. So you oftentimes will need to configure hardware differently for these different types of workloads. So for OLTP, because you've got high concurrency, you've generally got short transactions, and you've got a large number of connections to the database running concurrently. So you want a large number of fast cores. Here, the speed of the cores can really directly influence the speed of the application because you're doing single process or single threaded queries mostly. You want a large amount of memory to make sure that you don't have to do too much I/O. But if you've got, usually these OLTP databases tend to be smaller, so you might be able to just fit the whole thing in memory in the buffer pool. In that case, your disk performance might not be as critical for your data files on OLTP. However, the log file will be incredibly important because the log file is oftentimes the main bottleneck when you're dealing with a very fast OLTP application. So fast disk for your log file, but maybe data file disk is not as critical, and make sure you have enough memory to cover the primary data that's being accessed regularly. For OLAP or data warehouse, the individual core clock speed is maybe not as critical, but you probably want to have a large number of cores because your queries will be generally large. They'll be accessing a lot of data. They'll be doing a lot of parallel processing. So you want to be able to have enough processors to process those queries quickly. Again, large amount of memory because you generally are dealing with large data sets when you're dealing with an OLAP system. And here, I/O is incredibly important here because usually your critical path data is not going to fit in memory when you're dealing with an OLAP system or a data warehousing system. So the I/O performance is critical for an OLAP system. Okay, so disk considerations. So the type of storage you use, I don't care so much. I'm not going to sit here and tell you you must be using this kind of SAN device, or you must be using NVMe or SSD. There's lots of different storage technologies. What's important is that the specifications of that storage match your workload. So you need to make sure that you test your workload and that you understand the IOPS and throughput requirements for that workload. That's important on-prem, but it's even more important when you start moving into IaaS into the cloud, because that's how you purchase storage in the cloud, is based on IOPS and throughput. It's important for on-prem too. So when you're analyzing an application and trying to figure out what you need for storage, don't just look at the size of the database and how much storage you need, but also look at the workload, the types of IO that's being generated, the patterns of that IO, and make sure that whatever storage you choose has the right bandwidth to handle the IOPS and throughput of the application. Also, one thing to note here is SQL Server does not yet support 8K sector size drives. So when you're buying newer servers, you pay attention to the 8K sector size. If you do have 8K sector size drives, they may not work with SQL Server. So that will be coming in a future update to SQL Server, but it's one thing to note because we are seeing some newer servers that have 8K drives and they do not yet work with SQL Server. And then also, there are some other sessions out there on PMEM or persistent memory. There's some cool stuff you can do with PMEM these days in the SQL Server engine. So I also encourage you to take a look at that if you really have high-end IO performance needs. Okay. So virtual server considerations. Way back in the early days of virtualization, there are a lot of people who kind of formed this mindset that a virtual server is not the best place to run SQL Server, that you really should always run SQL Server on physical hardware. These days, I think that couldn't be further from the truth. I mean, there's so much that virtualization offers you as far as flexibility and resiliency and the ability to migrate your workloads across hardware and then also move them up into the cloud very easily. Virtualization is the way most people are running SQL servers today. So same kind of recommendations as physical servers for resource allocation. You're not really going to see a direct performance penalty from running on virtualization, provided that it's configured correctly. So it's not like you immediately take a hit across the board just by moving from physical to virtual. As long as it's configured correctly, it should run just fine. You have more flexibility, which I just talked about. And here, configuration of the host server is key. So when you're dealing with your virtual environment on-prem, you need to look at how your guest virtual machines are balanced on the hosts that they're running on, because it's very important for SQL Server to actually get the resources that it thinks it has. So what can happen sometimes with virtualization is resources are overcommitted, meaning we have more resources in the guest VMs than the host actually has. And the idea here is that the workloads will sort of balance. They won't all be, taking peak resources at the same time, and therefore I'm able to run more workloads on the same hardware. For SQL Server, that just does not fly because SQL Server is designed to run with the resources that it has available, and it changes the way it behaves based on how much memory is available to it, for example, how fast the I/O is, things like that. So if SQL Server goes to use some memory and it's not actually there, which can happen when you overcommit, the performance penalty is bad. It can be bad and noticeable, and it's worse than if you just didn't have that memory to begin with. So it's incredibly important not to overcommit. You want to ensure power management is set to high performance, and you want to also take care with how NUMA is configured. So NUMA is having different memory nodes and CPU nodes, and that can impact SQL Server because SQL Server will partition memory objects and other objects within the engine based on NUMA nodes. So it's usually a good idea to bring those NUMA settings through into the guest machine. Okay, so a couple infrastructure as a service considerations as well. Again, know your workload and tune before you go. This is even more important in IaaS than it is when you're running on-prem. Because when you go to IaaS, it is a consumption-based model. You are buying consumption. You are buying a certain number of vCPUs. You are buying a certain number of IOPS and a certain amount of IO throughput. So it is important for you to know how much you need before you get there. So when you're on-prem, you have this tendency of just buying a big machine, buying a big fancy SAN, and then you've got that. It works for you for several years. You're not thinking about, well, how many IOPS am I generating? How much throughput am I generating? If you're only using 20% of the CPU, it's fine. You bought the server already. You're not really wasting money. Once you get to IaaS, if you're at 20% CPU, you're kind of throwing money out the window. So you want to be really careful to know your workload, and also tune before you go. If you're getting ready to migrate a workload up into the cloud, it would really benefit you to get some tuning done on-prem before you go. I can't tell you how many times I've been telling people about this analogy. Like when you move to a new house, clean your garage out before you go. Don't throw everything into garbage bags and take it with you, because what a waste of resources, right? So don't move your junk with you. Tune those queries. Look at doing things like turning on compression, anything you can do to kind of slim down the footprint of the resources you're using on-prem will make the transition to IaaS so much smoother. So streamline the application before you migrate if you can, because throwing hardware at the problem is a lot more expensive in the cloud than it is on-prem. So a couple basic sizing recommendations. David Pless and I did a presentation that was run twice this week about sizing virtual machines and running virtual machines in Azure. So I encourage you to, if you're thinking about doing this or if you're in the process of migrating to IaaS, to go find that recording and watch it, because we go into much more detail on how to configure this. But a couple basics for Azure. We generally recommend for SQL Server workloads that you use one of the memory optimized sizes, M series or E series. These are the ones that are best for most of your tier 1 workloads. So those heavy OLTP, large data warehouses, those kinds of things, start looking at the M series and E series first. And then if you've got more general purpose, lighter VMs, these I probably wouldn't necessarily consider tier 1 VMs. So, some of your more general purpose SQL servers can use the general purpose VMs, which would be the D series. Use these for like development or test systems. But for your tier 1, you're almost always going to be looking at an M series or E series VM. And then I/O will likely be your biggest challenge when you move into Azure. And the main reason for that is what I was saying earlier, where you are buying storage not based on the size or the capacity, but based on the IOPS and the throughput. And a lot of people just don't know how much they need. So if you're migrating an existing workload, measure how much you need, monitor that on-prem workload. It's really just some basic perfmon counters like reads per second, writes per second, read bytes per second, write bytes per second. This will give you your IOPS and throughput. Monitor for that, get your peak requirements. Also monitor while you're doing maintenance, like backups and index rebuilds, because that can really drive up IO and throughput for a short period of time. So do that monitoring when you're on-prem. Make sure you're getting the right VM size that will give you the IOPS and throughput that you need. And then also we have a lot of best practice recommendations for how you would configure it, how you would configure storage. There's a link on the slide here, aka.ms/SQLIS-perf. So go there and we've got a huge pile of best practices for how to configure this. So in short, premium SSD for your data files, and you want to turn on read-only caching, host caching. This is a Azure specific caching, which is huge for SQL Server workloads. You're just leaving performance on the table if you don't turn that on. So premium SSD with read-only caching for your data files. For your log files, if you can, if you have Ultra SSD available as an option, it's region limited, so not everyone can use it. But if you can, that for your log files is great because it's super low latency. If you don't have the option of using Ultra SSD, you can use premium SSD with write acceleration if you're on one of those M series VMs. So the M series VMs offer this write accelerator, which can help with latency against the transaction log. But for your log drives, you want to make sure that you set the host caching to none for your log drives. And then we recommend that you move tempdb to the local D drive, which is the ephemeral drive. It goes away when you shut down the VM. The nice thing about that is, tempdb goes away when you shut things down anyway. So that's a good place for that. And then that can give you, it doesn't count against your VM level remote IOPS. So that's a way that you can get some local fast storage that doesn't take away from your data drive IO and throughput. And then also you can stripe across multiple drives in order to get better performance. So you can create a storage pool in Windows and have multiple premium SSDs, and that will give you better IOPS and throughput. It's usually better to have multiple smaller premium SSDs in a pool than to have one large premium SSD, because you will get more IOPS and throughput from pooling together smaller drives than you will from getting a larger drive. So what I mean by that is you can just get, I think it's a P50 that's a 4 terabyte drive, might be a P60. Anyway, you can buy like one 4 terabyte drive, and that gives you some amount of IOPS and throughput. But if you string together 4 P30s, you still get 4 terabytes, but you get a whole lot more IOPS and throughput. So you usually do better pooling smaller drives together rather than going with larger drives. And then there's a whole bunch of recommendations. So I definitely encourage you to go to that link and look at all the different recommendations for configuration. That should be, if you are moving SQL Server into IaaS in Azure, that link, you must go there first and make sure you get everything configured right. Okay. Server OS. I don't have a whole lot for server and OS configuration, just some super basics here. This should be obvious. Apply the latest version of the OS if possible. Obviously, you want to take advantage of innovations over time and keep things updated with cumulative updates. Power plan for high performance. This is what allows the CPU to be at the top clock speed. Otherwise, it's balancing performance with power consumption, and you don't want that for SQL Server. You want this thing to just be high performance. Paging file, you know, there's always these questions all the time. How big should my page file be? Where should my page file be? Page file just, it's like, it's old school, right? So if you're doing paging on a SQL Server, your performance is going to be so bad. Where that page file is just really doesn't matter. So really you want to be looking at making sure that you have enough memory for your workloads, and you don't have to worry about paging files. So don't waste a huge amount of disk space. You don't need a giant page file that's no longer the 2 times or 1.5 times size of memory. If you are actually seeing that error for SQL Server memory being paged out, add more memory. Don't worry about how big your page file is. Just make sure you've got enough memory to take care of your workload.
Can I just say something?
Yeah, go for it, Pedro.
It's important to keep in mind that especially when you're experiencing problems and you never know when that hits. The page file is still used for kernel memory dumps. So in case you need that from a troubleshooting perspective, you want to have a page file, and you want it to be, I mean, it doesn't have to be one-to-one to memory, obviously, because we have servers with terabytes of memory today, but you want it to be somewhat sizable. So we have guidelines in the notes of the slides that we're going to send. Please check those out. Those guidelines may help you kind of get to the sweet spot.
Awesome. Thanks, Pedro. I forgot about the kernel memory dump. I'm usually on top of that. Okay. So NTFS, we have not changed. A lot of people keep asking us, have you changed any of those recommendations for how to configure NTFS configuration? The answer is no. The IO patterns for SQL Server really haven't changed that much over time, in spite of having new features added and things like that. So still format your data and log drives in 64K block sizes. And alignment is automatic. We don't even really have to talk about that anymore. That used to be a really big problem for IO for SQL Server. So if you're still running, I don't know, Windows 2000 and SQL 2000, that's important. But if you're on one of the modern versions of SQL and the modern version of the OS, you probably don't even have to worry about alignment. And then we do recommend that you turn off NTFS file encryption and compression to get the best performance. If you want to leverage encryption and compression, you can do that through SQL Server. That's going to be much faster. Okay. And then I think it's time for me to hand off to Pedro. I'll let you take over, Pedro, and take us into the SQL Server configuration. Thanks,
Pam. So now that we kind of got a gist of what the most important aspects we need to take care of about how do we build or put together our machine, the infrastructure that we're going to be running SQL Server on, there's a number, and you've deployed SQL Server there, there's a number of configuration best practices that we really think are baseline for every configuration. So one aspect that we actually run across more often than we should, to be very honest, is about licensing, and licensing has a direct impact on whether you're using all the resources that you've put together in those Tier 1 machines or not. So back in SQL 2012, we introduced 2 forms of licensing. There was CAL-based licensing, and then we introduced core-based licensing. Now, these licensing models, they actually are enforced in SQL Server binaries, the ISO images that you use to install SQL Server itself. So you need to take care of downloading the appropriate media for the licensing that you want to. Otherwise, you'll get limited. And in earlier versions like SQL 2012 or 14 or even 16, it was not so easy to understand if you were getting limited or not. Now, what kind of limitation am I talking about? For core-based licensing, if you install, as the name would suggest, the enterprise core binaries, then you get to use all the cores that you have available on your server. Whereas if you are actually using the CAL licensing, you'll be restricted to 20 physical processors, or if you're using hyperthreading, 40 logical processors. So it is really important in those Tier 1 machines. Now, as I said, in more recent versions of SQL Server, like 2016 and above, you can watch for this error message in the error log. And in this case, because I installed a cal licensing on my server, it's telling me, hey, you have 48 logical processors in your and 24 processors in per socket in your machine, but guess what? Because you installed the cal licensed media, we're only bound to 20 logical processors, or 40 if I'm using hyperthreading. So it's really, really important to take care of that. In SQL Server 2019, however, if you try to install a cal licensed media onto a server that has more cores than its limit, you'll get this nice warning there. And you will, if you are indeed trying to install that purposefully, you'll need to check the checkbox there in order to advance with setup. So that just, in these cases, really allows you to stop in due time and go in and get the proper installation media if you were doing this in error. In previous versions, this can actually be completely silent. So if you're running older versions of SQL, I would recommend you go to the error log and look for that error message and see if you are being hit by this. If you are, then you are likely using the wrong licensing, and you need to upgrade that. Okay. So with that out of the way, let's really talk about settings for SQL Server itself. And we start with NUMA. Now, NUMA stands for Non-Uniform Memory Architecture, and it's really important for SQL Server because it allows it to kind of spread out and even out resource uses, not only in terms of memory, but actually in terms of compute also. So it's important for SQL Server Memory Manager to be able to spread out potential memory access contention by now having this NUMA architecture, but also it really helps with thread scheduling, with actual processing of your queries. In essence, if you think NUMA will be, you have a small set of processors within the larger scope of your hardware, and that smaller scope of processors owns a specific area of the memory and possibly even has its own I/O channels to and from that memory. So everything is more local, in smaller scale, can cooperate with other NUMA nodes, but it does have that potential to really help in terms of scalability and performance. Also, SQL Server is highly attuned for NUMA because each of these NUMA nodes, so-called NUMA nodes, will have some specialized tasks that exist one per each NUMA node. For example, if you heard about Schedule Monitor or the Resource Monitor, or even the Lazy Writer, it's something that probably Pam will talk about a little bit later today, or at least in the tempdb session, you completely talk about that. Each of these NUMA nodes has their own threads, and so it can do a lot to help curtail any bottlenecks. So it's also important to understand that if you're running in a virtualized environment, and if you're using, like Pam mentioned earlier, if you're using your host to emulate NUMA, which in essence would be soft NUMA, avoid having partially overlapping NUMA nodes. Meaning, for example, in terms of processors, don't have NUMA nodes that overlap in a specific one or more CPUs in those. Because if you do, you'll create concurrency at the hardware level that SQL Server is not aware of, and you may hit sudden bottlenecks. For example, SQL Server expects that it has 4 processors per NUMA node, and suddenly one of those processors at the hardware level is overlapped with another NUMA node that maybe belongs to some other machine or even the same one, and in that specific processor, you now suddenly have more workload than SQL Server expected, trying to run on the same compute resource. So that really adds overhead. Also, auto soft NUMA. Now, SQL Server itself is not only auto soft NUMA aware, it will implement soft NUMA automatically for you in case you're running in a NUMA configuration, a hardware that implements NUMA configuration. And most modern hardwares you are looking at NUMA configuration because with multi-core processors, each of those sockets will in fact be one NUMA node for all intents and purposes. So As I said, SQL Server is aware of NUMA and it can automatically implement soft NUMA, which is in essence further subdivide your hardware enforced NUMA nodes into smaller units. Why? Again, it's all about being able to scale better and to better cope with scheduling and a good use of memory. So it's enabled by default starting in 2016 or later. And if in essence, it means that if SQL Server starts up and encounters a server that has more than 8 processes per NUMA node. So in other words, for example, you are running in a server that has several sockets, several physical processors, and each processor has multiple cores. If each of those sockets has more than 8 cores, which starts to be common nowadays, SQL Server will understand that and will further subdivide into additional NUMA nodes, the so-called soft NUMAs. And if you are running on older versions like SQL 2014 SP2, you need trace flag 8079, as you see there. One thing that's important to consider is soft NUMA is an integral part of how you, let's say, calculate your optimal max DOP from a generic standpoint, from a best practices standpoint, and we'll get there. Talking about max DOP takes us to parallelism. Parallelism is all about the ability of SQL Server to use multiple processors or multiple schedulers, more appropriately, for parallel plan execution. So there are a couple of configurations that you need to take care of in order to ensure that, at least again from a baseline, from a best practices perspective, you are setting up SQL Server to have more performance out of the gate. So the default of 0, which was actually the default before SQL Server 2019, is rarely the correct setting. You need to be more mindful than that. If you want to be very precise, it is completely workload dependent. So like Pam said, testing first is paramount. If you have the ability to test and understand if you have, let's say, parallelism related bottlenecks, and addressing those will allow you to find what's the best max DOP setting for your entire server, even though that then perhaps several specific queries will require additional tweaking at the query level. Now, why is this? Because, I mean, if you're talking about more OLTP workloads shouldn't be really driving parallelism, but an operational data warehouse may be driving more parallelism than obviously OLTP. And if you are going full analytical, that even drives higher degrees of parallelism. So it is really workload dependent. Most vendors, or if you're using a third-party application, may have recommendations that if they are support boundaries you will need to follow. Otherwise, if you're not testing and if you want to just have that magical number, if you will, our approach is fairly simple and completely documented. If you're not running in a NUMA architecture, which again, it's fairly rare these days, just set the number of the max DOP to a number no higher than 8. Now, it needs to be the number of logical processors you have on that SQL or no higher than 8. If you are using NUMA, even if SQL Server has enacted its auto soft NUMA configurations, then set the number of logical processors in a single NUMA node. And you can do this even easily using SSMS. If you go to the max DOP page and you start expanding the CPUs, you see those are organized by NUMA nodes. So you'll be able to see even visually, very simply, how many logical processors you have or schedulers you have per NUMA node. So set it to, again, 8, or sorry, the ceiling of that single NUMA node and no higher than 8. If you are using SQL Server 2016 or above, however, we have changed this recommendation. Through intensive testing, we actually found that you can relax that up to 16. And that has to do with changes in scheduling that started back in SQL 2016. So again, limited to the number of processors in a single NUMA node, no higher than 16. And as I said, in SQL 2016, starting with SQL 2016, you can do this at lower levels, at the query level, or even at the database level. You also have max DOP configurations there. Now, another setting that has to do with parallelism is cost threshold for parallelism. This is, again, completely workload dependent. I would say actually it's even more workload dependent than max degree of parallelism, because this essentially tells SQL Server what is the boundary upon which it will essentially say that, yes, this query plan needs to be executed in parallel or not. So this setting has a lot of impact in the query processor, specifically in the query optimization stages, where SQL Server will determine whether parallelism can or should be used for a given machine or not. So there's no magic number around this. And because there's no magic number around this, the default of 5, although it's an old standard, it's still fine. Like in my 20 years of using SQL Server and talking to a lot of people that are in our support, it's very rare that we have to go to a case where this setting needs to be changed. However, if you detect problems, test with it. For example, you have what you thought should be low cost OLTP workload, and you're seeing it's going parallel. Well, first of all, you would need to understand why it's going parallel. Why does SQL Server think it has such a high cost? That should be the first avenue, because if it has a high cost, maybe you have problems with actually generating the plans to begin with. You can administratively address the issue by upstaging the cost threshold for parallelism value, but it's kind of using a hammer to address a problem. I would very much recommend against blind changes to this setting, like some blogs suggest. But again, you do your own. I think our practice tells us that there is no single magic number, so therefore the default is fine. If you are using SQL Server 2019, you'll see that during setup, we actually already have some recommendations in terms of setting this max DOP out of the gate. So we use the best practices that you just saw in the previous slide and that we have fully documented to detect how many logical cores you have on the machine that you are installing SQL Server on, and then use that to calculate the optimal max degree of parallelism for that specific instance. So this is the way for you to do this during setup and don't have to take care of that after setup. And sometimes perhaps you would forget. So this gets determined right from the get-go, which is why I was saying before that the default was 0 up until SQL 2019. Starting with SQL 2019, it's not 0 anymore, because during setup, either during the graphical setup, as you see here, or even in using the command line, you will see that the default will be to enact a specific max DOP based on what we detect on the server that you're installing on. Other settings have to do with memory. And keeping in mind that SQL Server does its work best when its operations work in memory only, meaning that paging and spilling to tempdb and all those operations are, let's say, make-dos in case SQL Server cannot run everything in memory. But memory allocations in SQL Server are paramount for good throughput and for predictable performance. So the rule to set max server memory, which absolutely should be set, should not be left at default. You'll see some write-ups out there, and even in our own documentation page, we have a fairly, let's say, laborious rule on how to find your optimal max server memory setting. Now, there's a common rule of thumb about, oh, just set it to 85% of the memory, and that's fine. That's not appropriate for all workloads. That's likely not appropriate if you have a machine now that has 2 terabytes of memory, and 85% means that you're leaving a lot of memory possibly unused. SQL Server will likely not need all that memory. Again, your mileage may vary depending on whether you're using in-memory LTP or not. But the point is, most of SQL Server's allocations will fall under max server memory. So therefore, you wanted to have a set limit so that other operations that exist in any given server, even for the OS itself, can still work. And then SQL Server itself also has memory allocations that are outside max server memory. For example, I mentioned earlier about scheduling, thread scheduling. Now, to schedule a thread, to be able to do compute work, SQL Server needs memory not only for allocating the pages and whatnot, but actually to manage the thread, the thread, to do thread management itself. So that memory is also allocated outside max server memory, and some DLLs, for example, some third-party DLLs are loaded outside this. So you need to take care of leaving some buffer to the OS itself. So an example, let's say if you have a 64-bit server with 32 gigs of RAM and 32 logical CPUs. There's a few data points we need to keep in mind that allows us to quickly build this formula of what should be, again, without testing, our max server memory setting. Well, we're in a 64-bit architecture, so we know it's documented that each stack will take 2 megabytes. And to get further into what stack size is and whatnot, please look at the documentation. It's thoroughly explained there. With 32 logical CPUs, we also document how our SQL Server finds the default number of worker threads if you leave that setting at default. So with the 32 logical CPU, it will be 960 default worker threads. If you leave roughly, again, rule of thumb, 4 gigs for the OS, that's roughly 6 gigs that need to be taken out of whatever is the total amount of memory you have in your server, in this case 32 gigs, which leaves me with setting the max server memory to 26 gigs. So all of these data points and the formula itself is thoroughly documented. If you go and search for SQL Server memory server configuration options, you'll find it, and you'll be able to set your own. Now, min server memory is also important, and the default will be fine for most workloads. There are, however, a few scenarios where we also want to configure min server memory, especially if you're running, for example, failover cluster instances, and you have the ability of several, of potentially in the same node, several instances coexisting. You want to look at this setting as what is the minimum amount of memory, not the optimal, the minimum amount of memory with which my workload for this instance is good enough with. If it needs to run crippled, it's what is it good enough for? So that's also applicable for running on VMs with potentially overcommitted hosts, although obviously you don't want to do that, or just simply running other SQL servers that are installed on the same node, even if it's not failover, because different instances of SQL Server don't know about each other. So you need to use these settings to be able to segregate the amount of memory that's used. You may have some overlap at the top, so at the max server memory, because it's fine to have some concurrency. Modern operating systems can deal fairly okay with that, but you need to set up min server memory for these scenarios as your min bar. And again, in 2019, we have made changes to the setup in order to, again, try to find, based on all these settings and these formulas, try to find what should be perhaps the good enough, untested max server memory for your instance right there. So this one, unlike MaxDOP, is not default. You need to opt in. Otherwise, if you just, for example, run setup with clicking next, next, next without looking at any option, you'll still end up with the default max memory setting. However, you may choose to either go with the recommendation. For example, here in this case, it was recommending me to have 124 gigs of max server memory, and I would need to click on the recommended box right there. If I'm running through command line, I also have the respective setup options. Again, these are opt-in. The MaxDOP we saw is opt-out. Okay. Large pages. So I'm going to try to pick up a little bit here because we're probably running out of time now. Pam talked about the page file, and now it's important for SQL Server not to page because it's designed to work best in memory. It doesn't know that in instances where the OS chose to take a part of its process and dump it into disk, it thinks it's still working in memory, and then it's not, it's working in disk. So that leads us to the conversation about this setting, the lock pages in memory. Actually, it's not a SQL Server setting, it's a permission you give to the SQL Server service account. Now, this is a good idea to set on most servers. much like Mac server memory, by the way. It's highly recommended for very large memory footprint machines. And we have this rule of thumb, like 0.5 terabyte or up. You definitely need this. It is needed for old school large page allocations. And I'm going to talk about why I'm saying old school in a little bit. The important thing to keep in mind is that with this permission given to the SQL service account, SQL Server will not allow the OS to page out parts of its memory. So in essence, the SQL Server Memory Manager can already receive information from the OS if in case the OS is going into a memory starvation scenario. And it has its own mechanisms to release memory back into the OS. So by allowing SQL Server to keep its memory, and but with this setting, we're allowing SQL Server to manage internally its own memory, to still respond to the OS in terms of in cases of memory starvation, but not allow half of its process to be administratively put into the page file, from which it's very hard to recover, and you need to reboot the instance in order to get away from that. So large page allocations. Now, this is the other scenario that typically log pages in memory also allow. To use large page allocations for the buffer pool, for column store, for in-memory LTP, typically you need to enable trace flag 834. This is a very good best practice to enable large pages, especially for machines that run with a lot of memory, run heavy analytical workloads. You'll notice that it will just handle better memory allocations and memory management. However, large page allocations overall, because they're allocated even at the system startup, they're not supported with column store indexes. So if you're using column store indexes, you're left with the conundrum, which is, hang on, but you're telling me that I should be using large page allocations for analytical workloads. I have column store indexes, which are, according to you Microsoft, best suited for my large data warehouses and really help with analytical workloads. So where am I? So that's why in SQL Server 2019, we have another trace flag, 876, that will allow you to set large page allocation model, but just for column store. So SQL Server does not allocate all that memory at startup, and B, SQL Server will use large page allocations for column store, but will not permanently hang on to that memory. It will relinquish it once its need to support the column store index operation is done. So in 2019 and above, if you are using analytical workloads and you have column store, you should not enable 834, but you now have trace flag 876 to enable and to get you through. Some I/O considerations. I'm going to go a little bit faster through this. These are settings in SQL Server that will have an impact on how a SQL Server is able to perform certain I/O operations. For example, the setting about the feature on SQL Server about instant file initialization. What is it? It's basically a boost in performance, because when SQL Server is either creating a new data file or extending an existing data file, and this applies to data files only, instead of zeroing out at the bit level, zeroing out all the sectors that it just allocated, it will not. It will, for example, if I'm growing a file, it will grow from the logical extents that are needed, but it will not zero any data that perhaps was already in those disk sectors. And as data as the space gets used, those get written with the new data. This really saves time and I/O cycles during these operations about growing files or shrinking files. So starting with SQL 2016, you can do this at the setup. There's a checkbox for you to turn on instant file initialization, which in essence means provide the SQL Server service account with the ability, or the OS permission, that's called perform volume maintenance tasks. And with it, it can use this feature here. Starting with SQL 2019, you can even do this post setup in the SQL Server Configuration Manager. And even though I'm talking about the SQL Server 2019 Configuration Manager, you can use it with by connecting it to lower version SQL servers and still do it there. About file placement. Now, this seems a little bit old school, but it's still important. It's less important from a physical standpoint to stripe at the file level, because as Pam discussed, you will probably have strategies around striping your volumes, and therefore SQL Server will still see a single one. You don't necessarily need to go to multiple files. Unless you are spreading across multiple VHDs, for example. And that may have to do with your needs to do management operations rather than performance perspective. One thing that's important, though, it's within each file group, all files, all data files should be the same size. If they are the same size, if you can ensure those files are the same size, SQL Server can use something called the proportional fill algorithm. In essence, going through a round-robin fashion, writing in your data files inside a single file group. That is especially important for tempdb, and you might recognize it from as a tempdb recommendation, although this applies to every file group. And as Pam mentioned, if you're using IaaS, storage spaces it's a great way to create those logical partitions across multiple disks, across disk stripes, and rather than using old school striping of database files. These are the differences between the configuration manager. On the left, the 2017 version, where you see, I mean, there's a number of options, but there's nothing around instant file initialization. And on the right, you see there that the configuration manager for SQL Server 2019 now has an option for you to set instant file initialization, and also to set the log pages in memory permission. So you can do both of them from this config manager, even though I can connect it, as you see on the top there. I'm using the 2019 config manager to connect to a SQL 2017 instance, and I'm still doing these changes. Let's go to trace flags, and this has a lot to talk about here. If you want to know about all the documented trace flags, the list is very lengthy, and you can go use this. You can use this short URL to get there. Now, there's a few I want to talk about. Again, we're in the scope of Tier-1 servers running Tier-1 workloads. For SQL Server 2016, 17, and 19, these are the list of trace flags we consider to be important for you to enable. The list is considerably shorter than in previous versions, and that's because many of these behaviors that throughout the years have been made default in the engine or can be used through other types of settings and configuration options, so we stay away from trace flags if we can. A few I would call out has to do, for example, with query store scalability. Those you can read more about in the short URL you have there, aka LSMS SWAC QSBP. But others, such as the ability, for example, to do to change how statistics are updated. If you have a large partition table, you may find that in a large partition table, it takes a longer time to, even though we have by default a linear update threshold, it will take longer to update data in a large partition table because it needs to achieve a certain amount of modifications. However, let's say you made a lot of modifications to just a small subset of the partitions, still not enough to trigger auto update over the entire table, but perhaps queries that are meant to read data and have predicates to read data from that partition are now coming up with bad plans. And that's because a lot has changed in those partitions, but not enough to trigger automatic update of the old stats. So with this trace flag 11024, what SQL Server does is it can trigger auto update if per partition the modification counter goes above the threshold. So for example, that is super important there. One other I would like to call out is 4199, which basically enables all the query optimizer fixes that are not enabled by default. No query optimizer is ever enabled by default after RTM version. So while I have rarely seen, actually I've never seen issues coming out of enabling this fix, I need to be conservative here. So if you're going to enable optimizer fixes, test your workload first. This can also be set at the database level with a configuration rather than a trace flag. So I urge you to do this before you just go and enable that trace flag. If you're using other versions, older versions of SQL Server, you need to turn on all of the above, plus this other list that in more recent versions have been made default behaviors in SQL Server itself. For example, the famed trace flag 1117 and 118, which had a lot of bearing on how you set up a system for a good throughput on tempdb. These settings are now enabled by default for tempdb, so you don't need the trace flags anymore. I just mentioned the linear recompilation threshold for statistics. In these older versions, you need trace flag 2371 to enable those. In more modern versions, that's enabled by default. So these other ones are also very important, and this makes up the entire list of what we would consider fundamental trace flags for you to enable in your Tier 1 server. Now, Pam, with tempdb.
All right, thanks, Pedro. I have done numerous presentations on tempdb, so I won't go into too much detail here. I'm just going to summarize. So tempdb is incredibly important because there are a lot of things that get dumped there. Spools, when you're running queries, sometimes get dumped there. Your row versions for snapshot isolation, your temporary tables that you're creating yourself. There's so much in here, and it is performance critical. So you want to make sure tempdb is on fast storage. It does not need to be redundant because tempdb gets recreated every time. So don't waste any fancy RAID on this, just fast storage. So SSD, even PMEM or NVMe, flash storage, whatever, you can get super fast storage for tempdb. You want to have multiple data files. This is not, they don't have to be all on different drives. They can be all on the same drive because this is not an IO optimization. This is because of some in-memory contention that we can get. So this is still a recommendation even in 2019 because we can still see contention on GAM pages, which is one of the reasons we need to have multiple files. So start with one data file per logical processor up to 8. For most workloads, you don't need to go higher than 8 tempdb files, even if you have, say, 16 or 32 cores. But if you do still see contention, you can keep adding more files. We generally see it's a good idea to add them in multiples of 4. For some reason, that helps with the round robin algorithm. So we recommend you add them in multiples of 4. They must be equally sized. And when you are adding new files, while a restart of SQL Server is not required, you can just add the new files. The whole point of having multiple files is so that if they're the same amount full, then we will round robin between them. But if you add 4 empty files, we're going to hit those 4 empty files until they get the same amount full as everything else before we start round robining across all the files. So if you can, it's a good idea if you want to add tempdb files to go ahead and restart the service. Otherwise, you might end up having more contention until those new empty files start achieving the same level of fullness as the rest of the files. So starting with SQL Server 2016, the setup itself will configure this for you, so then you can do this during setup rather than having to do it after the fact. And of course, upgrade to the latest version to get all the new fixes and enhancements. We have made many changes to tempdb, especially in 2016 and 2017. So make sure you're on the latest cumulative updates. If you're really having severe tempdb issues, see if you can upgrade to SQL Server 2019, because in 2019, not only do we have the new memory optimized tempdb metadata configuration option, but we've also done some major cache improvements, and we've got concurrent PFS updates. So that PFS contention that you've probably been fighting with, if you've been a DBA for a while, you've been fighting with that probably your whole career. That just magically goes away in 2019. So I'm cautiously optimistic that there will be a future where you don't actually have to add multiple files to tempdb. It's on the horizon. I can see it now. Okay, so that's tempdb. And then the last section, we want to just segue into some application related things. We are at the top of the hour, but technically we have 75 minutes. So we'll try to answer your questions in the background. We'll cover a couple of these topics at a high level, and then we'll try to just keep answering your questions on text in the background. And then if we do have time to do some live questions, we'll do that as well. Okay, Oh, so partitioning, I want to talk about this just a little bit because this is always a question. Like some folks will ask me the question, how big should my database be before I start partitioning it? And that's just not the right question to ask. It's not like you reach some magical threshold and then you partition your database and then it suddenly gets so faster. It's not really like that. Partitioning is great for very large databases where you have tables that are, gigabytes large, but it's not necessarily going to automatically make your queries faster unless your queries can actually do partition elimination, where you have in the where clause the same condition that's used as the partition key. If you can't do that, then your queries could actually get slower with partitioning. It's not a magic bullet. So what it's great for is enabling fast archiving, sliding window scenarios. It also allows you to do create read-only file groups so that you don't have to back up the whole database. You can just back up the read-write file groups. So it enables you to manage data better, but it's not a magic bullet for performance. So it's not like you partition your table and then suddenly all your queries get faster. We've had some customers where the opposite is true. So there's definitely more management involved in this. And you only want to do it if it makes sense for this particular data set. So you want to find an optimal partitioning scheme based on the business requirements of the application. So if there's a date-based partition because all of your queries are date ranges, then that might make sense. There may be some like logical key where the data is partitioned where you only query one subset of it at any given time. So if there's a natural partitioning key available, then that's great. Otherwise, it may not make sense for you.
Well, you can always create surrogate keys, and we have customers that have scenarios that the database design is so ancient because it's from a legacy application that they never got around to, in due time, architecting for a possible partitioning strategy. So you may still get away with it with a surrogate key. However, like you said, you need to then use that surrogate key in your predicates to use it properly.
Right, exactly.
Just wanted to make that point. Sorry.
Yep. Thanks, Pedro. And then if you do go with partitioning, you want to leverage partition aligned indexes. So what this means is that all the indexes that you create are partitioned the same way as the base table or the same way as the clustered index. This would allow you to do the fast switching and the archiving and the sliding window and all of that. It is possible, and in some cases, if you can't use the partition key to do partition elimination in your queries, you can actually create a non-partitioned index that works for that query, that can help the performance of that query. But the problem is having those indexes that are not partitioned means that you can't do the fast switching. So you want to leverage partition aligned indexes if you can. If not, you would need to drop those indexes before you can do fast switching.
And please be aware of that last bullet point there. We should have that in red.
Oh, beware
the way you write your queries.
Yeah.
Yes, the way you write your queries, there's a lot to do of how well SQL Server can use partitioning to speed up the queries, as Pam was saying, or actually slow them down. You may have a perfect index design and you have the perfect partitioning scheme that would potentially allow you to read just a really small subset of the data to retrieve whatever results that you're looking for. But suddenly, if you have a top keyword there, and the order by is not narrow enough, if you have a min or max function in your predicate, guess what? All bets are off. We'll scan our partitions.
Yeah.
So keep that in mind.
Yeah. Okay. I'm handing it back to you for collation. Take it home, Pedro.
Thank you, Pam. So it's collations and encodings, and it's really important when we're designing a database for an application, or we're installing a new application that already has a predefined schema, to really think about what collation am I going to install SQL Server with. So beware of user database collations that are different from system database collations. If you are installing a SQL Server on which you'll have databases from a specific vendor application, for example, then look at the vendor application documentation or talk to those folks and understand what is the collation that they require in SQL Server. Because if a database is defined using a collation that it's different from the system databases, namely a master and model, that means that then, for example, tempdb also gets the collation of the system. And then if the application is not set up to really handle potential collation conflicts, you can go from silent wrong results to even being prevented from executing your code. Think about a database where, without the application taking care of anything specific, you have a collation that sets a different sort order for your system databases versus your user database. It may happen that if a sort spills to tempdb, and if the application is not in the comparisons that are being set in the query itself is not collation aware, that then you may have a different result. You may have a different result in terms of how you thought the sort should be returned, and it's not. Some products, like even our own SharePoint server, for example, will require a specific collation setting. So really look at the documentation for the product databases for which you are using SQL Server for. Now, yeah, you can even have these sorts of errors. For example, cannot resolve a collation conflict between two different Latin collations. If there's an equality predicate, and the equality predicate is between two tables or even two databases with different collation, you would think, oh, they're both Latin collations, they should work well. They don't. So you will actually have your applications failing if you don't take care of this at design time or at deployment time, better said. And then in SQL 2019, I would highly advise that you use the new UTF-8 feature. And that has really important considerations that I'm going to go through them very quickly here. If you want to read more about how to implement UTF-8 and a lot of its benefits, not only from potentially a performance perspective, but also from a legality perspective. Some regions, some applications mandate the use of UTF-8, and there are good reasons for that. Please go to that short URL, aka.ms/SQL UTF-8, and you'll see a lot of documentation there. I'm just going to leave you with some considerations that going with UTF-8, or whether you should go with UTF-8 or not, and what you need to keep in mind. If your data set, if your databases use primarily ASCII characters, so basically, if you are mostly storing data that is Latin, from a Latin alphabet, then actually you should choose to go with UTF-8. Because that will allow you to have significant performance improvements and also achieve up to 50% performance storage savings. So when you compare, let's say, an NAND chart 10, which is UTF-16, with chart 10, which can be enabled with UTF-8, you'll see that there is literally half of the required storage. And chart 20, because nchar and UTF-16 is implemented with byte pairs, it literally requires 20 bytes of storage. Whereas you can store the same string in a char 10 with UTF-8 and just require 10 bytes of storage. And then that trickles up into operations that have to do with I/O. We've measured that when doing intensive read-write I/O on UTF-8, there's an average of 35% improvement over its UTF-16 counterpart. This is a table with a clustered index and a non-clustered index on that string column that we tested with. An average of 11% improvement if instead of a cluster table, you're using this on a heap. So again, if you're using Latin characters in most of your database, do look upon UTF-8. Storage savings, which if you're going to the cloud, as Pam mentioned earlier, you need to make sure that you are using the least storage footprint possible, because that will grant you some savings, monetary savings. This is a good way to achieve that. If your data set is predominantly what we call extended Latin, which has a higher character range, and we're talking about the Greek language or Cyrillic or Armenian, then choosing either UTF-8 or UTF-16 is fine. Both will use 2 bytes per character. Performance measurements that we had, fairly similar between both, so no differences there. If your database will use primarily East Asian characters like Chinese, Japanese, Korean, Thai, then you should actually choose UTF-16. As you see here, UTF-8 will use 1 extra byte per character. Both of these, UTF-8 and UTF-16, are variable width encoding, and that's why you see these changes depending on the character range that we're talking about. We actually measure 25% degradation for intensive read I/O when you use UTF-8 with these languages instead of UTF-16. So keep that in mind. And finally, if you are using your database to mostly store emojis and other characters in the supplementary character range, which probably you're not, then using both is fine. Because in UTF-8 or UTF-16, both encoding types will use 4 bytes per character. And as expected, there's also no performance difference there. There's a lot more to know about this. That's why I had that short URL there. However, do please bear that in mind when you are migrating your SQL Server or creating a new database. Now let's go over to database maintenance. And these are this is a fundamental task for any DBA that's listening in today. You know that you will need to maintain your indexes and even statistics to ensure that your workloads remain with that level of predictable performance. Mostly because indexes and statistics specifically are the building blocks for the query optimizer. So having accurate statistics and updated statistics is a good way to get started in terms of generating good plans. This may mean rebuilding or reorganizing indexes depending on 2 things. Not only the level of fragmentation, that is important, especially if we are talking about scenarios where you need to scan all the data. However, page density is also important. If you have a database that has low page density, that means that you can store less data per page, and so looking at fragmentation alone and not understanding what is the potential impact in terms of I/O usage that you have because other aspects are in mind, like page density, can actually make these maintenance operations a lot of just be hardship, just be a lot of overhead over your server. So you can implement there's some automatic or intelligent grooming, index and statistics grooming applications or scripts out there. There's AlloScript, there's adaptive index defrag. Those usually take care of looking at these considerations. We will be updating adaptive index defrag soon to also take care of looking at page density into its determination on whether an index should be rebuilt, reorganized, or actually nothing. Do consider using resumable index operations, especially when you're using AGs or on very large databases. Your maintenance window may not be long enough for you to do these operations. So the ability to pause an index rebuild operation and resume the following evening, for example, or whatever is your next window, is super important there.
Hey, Pedro, we've got about 2 minutes left. So okay, let's look at the rest of your slides and see what's really important.
Absolutely. Thank you. So updating statistics, we mentioned that. Integrity checking, I mean, if you have silent corruption, you'll probably get a tough spot. So do run dbc check db at the regular intervals. About query optimized and cardinality estimation, there's a lot to talk about here.
I just answered a question on 4199 that covers a lot of this. So hopefully folks can look back at that.
Okay, great. Look at these short URLs. There's a lot to unpack there, a lot that we recommend. So please follow that. The query store, it's the flight recorder for your database and your workload. So use that to your advantage, not only from troubleshooting, but also this week we announced at least one feature, C feedback, that's built on top of the query store. So this will become more and more important as a baseline for upcoming features around keeping performance stable, like automatic plan correction. So this is really important for you to enable and have it enabled in your databases. And finally, some links for you. If you can't remember anything here, remember the last one or the one before last, aka.ms SQL shortcuts. If you know that one, you'll know all the other shortcuts here and more. So hopefully this was useful. It was a lot to unpack. We'll be making the slides available and you can ask us questions afterwards. Thank you.
Thanks, everybody.